Hello everyone, hope you all are doing well. This is another step-by-step coding video where you are going to learn how to put a UI based on Gradio Python library on top of a text prompt-based GitHub project. The project which we have selected is the Stable Diffusion TensorFlow model where the prompt is available on your console to generate the image by passing your prompt as checked. One of the biggest advantages of this video is that there are almost 75,000 models loaded at Hugging Face repo, and I would say that 90% of these models are just there without having a GUI on top of it. So if you are excited enough and you would love to learn how to add the UI on top of these command prompt or the console based models, the learnings you are going to get from this video, you can apply to any of these models and build the very fine looking functional UI on top of these open source models by removing the console based prompts with a very functional UI. We are going to add the Gradio based UI on top of this code, everything from scratch, and we are going to use this UI to generate the image from the prompt by adding various other functions as described next. So in this video, you are going to learn to take a very basic prompt-based application where you are using the command prompt in a terminal window to generate the image output using your prompt and add UI on top of this to convert this application to a full-fledged web-based application. The final UI looks like something to this, where the code has been broken into several steps. So this is the prompt which generates the output based on input prompt. Here is the code in text to image.py which actually loads the model and they generate the image. So we add the UI on top of that prompt so that image can be generated based on the prompts. The settings can be set by a different tab-based UI and the model can be loaded in a different step. So the code which you are seeing here is split into the UI, where this line is used to load the model based on image height and width setting. This option to generate the model is the second tab, and these settings which are being applied to generate the image are split into the third tab. We add the web UI by using this code, where we connect the Gradio with the class named process prompt, which has been implemented in this backend.py. Here is the process prompt where you are using the Gradio based UI as designed here to set up the three different tabs. Each tab is responsible to perform a specific action. The very first tab is loading the Stable Diffusion model, and here is the code which really responsible for loading the Stable Diffusion model, setting up the class property to the generator here. The second tab is responsible to reading the prompt and generating the image as output, and that is the function which is responsible to taking the prompt, loading the generator, and finally generating the image and sending the output from backend to the front end, where it is rendered in the UI. And the third prompt is responsible for setting the generator specific settings to be applied on the Stable Diffusion model. The method which is responsible for updating the setting is update st settings, where UI is sending these properties which are going to be applied to the class as defined here. So the UI based settings update the default settings which are part of the process prompt class. So there is a lot to learn in this video, such as where the models are downloaded, such as when you are loading the model Stable Diffusion, that is the place where the Stable Diffusion class loads the model. Looking into the get models, you will see that these models are Keras TensorFlow based models, which are downloaded from the Hugging Face repo into your local file system. And as you could see, that these models are downloaded from the Keras and they are available in my local file system in the Keras dataset folder, such as Keras cache. And it's about 4 gig of these model files, which are responsible to generate the image which are being processed by this generate image from prompt code, which reads the prompt from UI and generate image such as this. So in this application, you are going to start from here and you will end up adding these two brand new files on top of text to image code so that your code will be able to perform the image generation using this UI. So before I start the coding, I just wanted to let you know that there is already a video I have created to explain the code as well as the functionality related with this project. So if you are interested to learn more about the background of this project, I would request you to please watch the video available at YouTube channel. So as you know that there will be a lot to code in this project. We are going to use the PyCharm as our IDE and Conda based Python version 3.10.6 is going to be our Python environment. While I will be coding this whole project in front of you, if you have any question, please feel free to write in the video comment and I will answer you directly. Our project name Web UI Code Part 1 has the full code coming out from the Stable Diffusion TensorFlow here. The folder Stable Diffusion TF is there and the text to image.py is here, text to image. Rest of the files I haven't used. The requirements.txt and requirements.m1.txt is also added in case if somebody would want to install the package related to our project. If I will expand Stable Diffusion TF folder and look into the contents coming out from here, that's why you could validate that the code, everything what we have here is fully integrated in our project. So it means that whole project related with debug Stable Diffusion TensorFlow is going to be part of our Gradio project. I have opened the terminal and we do have the Python 3.10.6 environment for this project. I will be using the same text to image.py to generate an image directly from this prompt. So make sure that the code which we have here is working as expected. So before I run the text to image.py, I just wanted to show you that this project is going to download these 3 different models from Hugging Face repo to the local file system. And these models are going to be stored into the Keras cache because I already have the Keras installed in this machine, which is needed along with TensorFlow. So let me show you where the Keras cache is. So at my home folder, we already have the .keras folder, and within the datasets folder, you could see that these are the 3 models: text encoder, diffusion model, as well as the decoder. All these 3 models are already downloaded. It means whenever we are going to run this code, these 3 models will be used to generate the image from the text prompt. And in the next step, we are going to use the text to image.py and generate an image using the prompt as well as the output parameter. And our prompt is a cute panda is playing guitar in golden tracksuit. And the output will be the panda.png. Our image is generated, pandas.png. Here is the pandas.png. We can open it. And based on our prompt, here is the target image. So you can understand the code does work from the text.image.py. It means we can add the Gradio UI on top of it So I will be creating the new Python code. We call it webui.py, and we will be using another file name backend.py. So these two files are going to be the front end code for our text to image.py. So at a very first step, we need to make sure that we do have ability to put a very simple Gradio UI on top of text to image, which just accept the prompt and generate the image. In the backend.py, we are going to create a class. It's called the process prompt object. And here we are going to define the init. Let's create some properties for our class. And this class is what is going to connect with our web UI. So here we can say import Gradio as gr, and if name is equal to underscore main, we can create the SD UI. This is our SD UI object is going to be gr.blocks. And at this point, we need to hook our web UI with the backend UI, which is just has the process prompt. So in the class, we need to create a method called the generate UI. And this is the code which is going to generate the UI. And this UI is actually going to have the hook from the web UI. So for now, I can just put a return false because I'm just creating the scaffolding to connect the front-end web UI initial code with the backend class code. And it's also going to have the UI launcher functions. So launch UI, and this is the code which is going to launch. So we need to make sure that this object, which is using the gr blocks, is actually available here. So we could actually say that this is our object which is going to be passed when the class is going to be initialized. So self dot, this object is going to have this object, and this is the object which is going to be launched here. So self dot launch. So this is our launcher, and this is the object which is going to be used to build our UI. So at this point, we can say SD UI equals to, we need to import from backend import process prompt. Here we need to create the class object. So we could say SD class object equals to process prompt. And remember, you see this sign, it means that whenever this class is going to be initialized, you need to pass the initializer, which is STUI object. That's why it's waiting for us. So once we put this thing here, now that warning is gone, at this point, this class object, which is being instantiated using the process prompt class, has to first generate the UI. So that's the generate the UI. Once the UI is generated, the next step is to launch the UI. So that's all the hook was needed for our initial code to start from here and connect our backend code. And just to complete this code here, we could say with self dot. So STUI object. So this is what we really need to use to generate the UI. So let's use the gr. Oh, we need to use import Gradio as gr. So gr dot markdown. So that is our header, and use the header here. In this scenario, our code is going to be run of instantiating the object, calling this method to generate the UI, and then finally launch the UI. And now we can come back to our application, change the configuration, and ask it to use the web UI from this folder. So this is the web UI, and it's using the Python 3.10. Okay, let's run the code. 7861 on port, and as you could see that this is our markdown. So in the next step, we need to connect our prompt with this text to image. So here is our text to image generator, which actually uses the code. So this is the text to image. If you look into, it's really using the TensorFlow. So we are going to take all of this, put into the backend. Next, we are going to use the code which generates the image, and I will create a method called define generate image from prompt. I will keep this code here, and looking into this code, we could see that we need to provide the image height. So for now, I will use the 512. Later, we will change them to variable. So 512, 512. The prompt will be passed by us. So we can actually use the prompt here. We don't need this. Steps, looking into the default steps. So the scale is 7.5, steps default is 50, and seed we can provide. So scale 7.5, steps 50. Scales 7.5, temperature 1, batch size 1, steps 50, and seed a particular number, and that's where the image is going to be generated. So as you could see here, when this prompt generates the image, that becomes the image, and the image is an array. So the very first index of this image is basically the image. So we could say that we don't really need to save the image on the disk right now. So we can keep this, just use this image, and that will be our return of the image. So this is our generate image from prompt method, which actually takes the prompt and generate the image. That's the basic change we have done. Now in the UI, we need to come back and add the very first tab for us. Let's come here with gr.tabs with gr.tab item. So very first tab item, we can say with gr.row with gr.column. So we are creating a very first column at the very first row. So we can create the text prompt, which is gr.text box, and our label is please input your prompt, and image out will be the final image, gr.image. And now we need to add a button here. So we could say image generation button equals to gr.button and generate image. In the UI, there will be a text prompt, there will be an image block where the output image is going to be rendered, and there will be a button which will be used to generate an event when the prompt is there. So let's add the click event, and the click event has been added at the tabs level. And if the click event has the 3 parameters, first we need to add the method. So that is our method. It will be self.method. Then we need to provide the input, we need to provide the output. So input will be the text prompt, output will be the image out, and that's what it is wired. So if you look into here, this method is wired here, which takes the prompt as an input, generate the image as output. And now because we have changed the code, so we have to rebuild our code and rerun it. So you could actually use this option to rerun. And as you could see quite simply that our UI is created. Here we could set up our prompt. Output image will be here, generate image. So let's create a prompt first. And let me use the prompt which was available in text to image. Here is the prompt. Let's generate image, see what happens. Here you can see that backend processing has been started. Here you could see that the GPU available in the MacBook has been used. And here is your image. So you learn two things, that when we are generating our prompt, there are two different methods happen. First, we generate this generator object, and then we use the generator object to generate the image. So very first step, we need to split these two processes. So first we will use the Stable Diffusion method to generate the object, and that's where we are going to call the load the model. Reason we are calling the load the model, because if you look into Stable Diffusion code, here you could see that whenever this stable diffusion code is initialized, it actually makes the call to get models. And get models is where the models are being loaded. This is the code. So our option will be to split this method into two separate methods. So first we call it load SD models, and this is the step which actually loads the model. So if we load the model, then we need to make sure the generator is available here. It means we can actually create the class initialized model called the self.generator and set it to none first. And once this model is available, then we can say self.generator equals to generator. So now this generator is actually going to be used self.generator. And reason why we have done, because it serves two big purposes for us. First, we are going to load the model, and second, once the model is loaded, then we can keep using the second prompt to keep generating the image. So these first two lines, when the model is really going to be loaded, we don't really need to run again and again, because if we keep using this method, we would have load the generator again and again. So even it's faster in subsequent run, still it's waste of resources. So let's come back to our UI and split the UI into two tabs. First, load model, and second, generate the prompt. So one thing you need to understand, if we split this code, you can see that there is an image height and image width is actually part of a stable diffusion class. It means if we try to split the UI, we need to provide the initializer for the image height and the image width. So let's create a new tab here with gr.tab item, load stable diffusion model with gr.row with gr.column. And here our inputs are two, image height and image width, and our output is actually nothing. So we just really need to generate a message that the generator has been loaded. So here we could say img input height is equals to, we are going to use the slider. So gr.slider label image height, and the value is going to be, because slider uses the value, so we could say that our image height starts from 64 to 1024, and the value we are going to use here, we could say value, the initial value will be 512, and the step, like every time when the slider will be moved, it is going to use a step, so use the 64 here. And this is error because it's expect us to have these value at the start, because looking into the slider, as you could see that the minimum and maximum are the first, then the label. So that's the reason if you put them back here, you are going to get the error, because that is not, unless you actually name them. So you have two options. You look into the slider property and say what is the value of minimum and maximum. So you could say either minimum is 64. Now you see maximum is not clear, or you could say maximum is 1024, and now you do not have that error. But if you do not try to properly explain to the method that what this variable means, you have to put the in proper positions. Similar to that, image input height and width, and same way. Output will be a label, so we could say model loader output is going to be the gr.label, and our label will be model status. Now let's create a button. So model loader button is equal to gr.button load stable diffusion model. So these are the properties which are part of our first tab where we are going to load the model. So let's use this button, generate the click event dot click. Remember, the first option is always going to be the method. So self dot load st models, first prompt, then the image input height is input, width is input, model loader message is output. Now we can go back to this load st models method. pass the img height, that's the this value, img width, that's the that value. And here we need to check if the generator is not none. So we can look into here stable diffusion, and as you could see here, the generator. So the generator is what is really going to initialize this thing. So we need to figure it out that how we know that the generator is okay. So if you look into here, that this class, stable diffusion class, actually has the text encoder model, diffusion model, decoder, and encoder, because that is what is really being used to generate the models. So we could actually check the condition of these properties to make sure the model has been loaded correctly, is not none. So we could say that output model status is model is successfully, otherwise you can say are not loaded, and that will be our return. So let me put a breakpoint here to make sure that we are putting up proper conditions to check the generator status. At this point, because we have split our code in two separate methods, so let's close the execution and rerun it properly. Let me close this log because I wanted to explain you through the log when the execution is going to start it. Run the code. This time the application is running and port is 7861. Now we have two tabs. First one is loading the model. Second one is just processing the prompt to generate the image. Let's load the model. As soon as we have started the loading model, we could see that the GPU in my machine is used. If you are not having GPU, it's going to use the CPU. And as you could see here, that model load status, it means this code, stable diffusion instantiation of this generator object, has been started. Once the code will come out from this method, we are going to hit this breakpoint. As you could see, that generator object is here. And sometimes when you want to check the condition, you always copy this, your condition. You go back to debugger and you check if this is true. So you see here generator is not none, or if you say generator is none, it's false. It means if you use this condition, you are going to get the result either in true mode or in false mode. One more thing you can actually check here is that you can look into the generator. Generator is having these properties. So you could say generator.decoder, and here the generator.decoder. So if you would want to check its property, you can say is none, is false, is not none, true. It means that you have ability to either you can just check the generator is none or not none, or you can actually go individually and look for each of these properties. Text encoder, diffusion model, as well as the encoder code is using the decoder and encoder as the same object here. So our code is okay. Let's jump. Model is loaded. The self.generator is set. It means our class, this generator property has been set to the generator, which we are going to use whenever we are going to generate the image from our prompt. Let's run it. So it shows that our model is loaded successfully. At this point, text to image prompt, we need to make sure that model is loaded, because what if people will come directly jump here and start putting the prompt? It means whenever we are going to generate the image, we can actually make sure that we can also show a status, and I will be implementing that next. But let's use the prompt first. Generate the image. We can look into the console. As you could see here, that image generation started here. And that is what we have received the image. Now, if we change our prompt by adding the art by Leonardo da Vinci, and if we use this second prompt to generate the image, you will see that what happens in our console. As you could see here, that the image generation just started, and the initial code where the model has to be loaded does not really need it. And that's how we save lots of time by reusing the pre-loaded model. And this is what the output is if we would have used the prompt as designed by Leonardo da Vinci. A stable diffusion model to generate your images, you can actually use this method called art by, and you can actually find the top prominent artist and you put their name, and you will see that how the art really changes. So we have got really very good understanding is that these two things are working. Now we just really need to add a little more code in our applications. For example, if user is going to select the generate image without loading the model, then we need to show a message here. In the generate output, we can actually, in this generate image from prompt method, we can return the status. We could say image generate status, and here we could say model is not loaded. Then we can check is image here, because before we try to actually use this self.generator, we make sure that it is not none, because you see here it is none by default. We could say if self.generator is not none only when we are going to use this image. So now you see here that image output. So we need to set up the image also here. So we could say that img out is also none, and img out is going to be set only when self.generator is used to generate the image. So these two conditions are okay at this point. And here we can change the model status, because if generator is not none, it means we can change this property, and we can say if img is not none and the length of img is greater than 0, only then we are going to set the image out. And at this point, the image generate status is going to be image is generated successfully. Otherwise, in this scenario, if the generator is not none, however, if there is any error by generating the image from prompt, we can actually say that image generation failed. So now you have a better messaging coming out from your prompt when you are going to generate the image. And because this method is returning two output, we need to fix our image generation clicker event. So here we could say image generation status, and this status is what is become a label in the second tab. Here is our second tab. Here we could say gr.label generation status. Let's rerun this whole code. At this point, if we just click here, as you could see, model is not loaded. Even if you try to put anything here, you press, it is not going to work because it shows that model is not loaded. Then if we come back here and select button, we will know that when our models are loaded. Let's remove this breakpoint because we know this code does work. So model is loaded. Now we can come back and put a prompt here, Pablo Picasso. And because in our method, let me show you here, we have two output. That's why these two status are shown in a way that the backend processing is going on. And when the results are going to be coming from backend to front end, then the Gradio UI is going to update the status based on output coming out for the each one of these Gradio UI component. And here is our output. And it shows that image is generated successfully. So we have got that part is working. Now looking into the generator code, as you could see that we have these variables. We have the steps, we have the scale, we have the temperature, we have the batch size, and we have the seed. So we are going to add the new tab, third tab is called the Stable Diffusion Settings. And we will replace all of these 5 values with the 5 input values as the Stable Diffusion Settings. And then we are going to set these values not as a variable, but they will be part of our class. So let's come back and implement the code. So first thing what we need to do, we need to create the settings. So we could say Stable Diffusion Settings. So first we need the number of steps equals to number of steps, and the default steps we are giving the 50. So this became self.number of steps. That's the guidance scale 7.5. Temperature is initial is 1, batch size 1, and the seed a random value between 1 to 100,000, we could use it self.seed. So these values, we have set up the class specific variables. It means in the UI, when we try to set these values, we can use the class properties to set them. And that's become very easy work for us. So I will be creating the third tab with gr.tab item, settings with gr.row with gr.column. And remember, these are all 5 numeric values, and we are going to create the slider with min max and the step for all of these 5 values. So we need slider. So let's copy this slider and reuse them again and again. So first is going to be the SD step. We just call it sampling step, and let's have the value. Minimum is 1, maximum is 100, value the default is 50, and the steps are 5. Then let's use the scale, and that's the guidance scale where the value start from 1 and goes to 10. The current value we are going to use the 7.5, and the step we are going to use the 0.5. After that, let's add the batch and the temperatures. We just call it batch size, value 1 to 10. Current value we will use as a 1, and step is also 1, and that will be the batch size. We are going to use the temperature. Value is 1 to 10. Current value is 5. Step is also going to be used 1. And then we need to add the last property, which is the seed, random seed value. The value we can say they start from 10,000 all the way to 100,000. Current value, let's use the 2424254, and step is going to use the 1000. And we need a button. We could say SD settings button, save stable diffusion settings. So that is our settings tab. Let's add the code for the click event dot click, and method will be the save settings or the update settings. So let me put here update SD settings, and remember this method is going to use the 5 parameters, and it's going to update these 5 values. So we are going to use, so first value we can use the number of steps, second value is going to be scale, third value is going to be the temperature, fourth value is going to be the batch size, fifth value is going to be the seed. Now we can look into that how we are sending the value. So first I think we are sending the batch size, then we are sending the temperature, batch size, temperature, then step, scale and seed, then step, scale and seed. Perfect. So that is our order of sending these 5 values, and our return is nothing here, so we don't really need to send anything out. Let's take these 5 values, batch size, so self dot update SD settings, input, output, first batch, second is temperature, third is step, scale and seed. So step, scale, seed. So these 5 values are input, output is nothing, and that's how this SD setting button is going to be used. Let's stop the execution. We will put a breakpoint here. So we just need to make sure that the settings which we have updated are working or not in our code. Let's run the code again. Launching. Now we have got this third property. I will keep the batch size 1 because of my GPU is going to generate the problems if I will change the batch size to more, and my code will not work because I already know this issue. So I'm going to be keeping the batch size 1, but I will change the temperature to 9. Sample step I will put 10, and then great guidance scale I will put low, and random seed value I will also change, and I will run this code. So I believe is that the settings are done. If you would want to add a notification or message, we could actually add it, or we could actually show here the current values. So let's actually add that code here. That would be even better. So what we can do, we can actually add a label here, SD settings label equals gr.label, and here we can say current settings. Okay, and initial value will be the not updated, and now the output of this method will be the settings. So let's put the settings here, update this method, value equals to So first we need to say, let's use this way. So the batch size is the batch self dot batch size. Next, temperature is actually self dot temperature. Sampling steps, guidance scale, and finally seed. So that's the value which we have generated, and our return will be, because this is the JSON value. So if we send the JSON, it's not gonna be really good method. So we could use stringifiers. So just take this, send as a JSON. So that is our return value, which actually reads the output based on whatever the current settings are in our class. Let's rerun the code, reload. Now we can come back here. You see that there is no label here, but if we set it here, now we know what is current setting. So if we change this, we can change this, we can change this, we can change this. Now we know that within the class, these are the class variable. It means we already know that when this result is being rendered here, this is what the internal settings for the class. So when this generate method is going to be called, it is going to use these values. Now, if we come back, generate prompt, you will see model is not loaded. Let's come back to here. Make sure that our model is loaded. So model is loaded successfully. Let's build another one. So we can say landscape, heaven, concept, art, and we can say it's a Final Fantasy 3D design. And we can also say that this is actually the trendy art. That's at this point, if we look into the class object, we can actually check the values. Num steps are different, guidance is scale, temperature, the batch size, as well as the seed. Everything is based on the settings which we have set in the UI. And here is the output based on our prompt. This is what the heaven concept art, similar to Final Fantasy with 3D design, and looks more the trendy art. So in this part of the video, we have added the 3 different tabs. So in the next step, we are going to enhance our existing code by saving the prompt and images. Something similar to this. It means, as you could see, that all of these previously prompt and images are saved, and using this drop down, we are retrieving the image and prompts. So that will be the step 1 in the next video. And as you could see that we have added these different properties in our prompt. So we are going to enhance our GUI by adding these properties. Here you could see that here is the art choice, the different art, and then artist name, and other properties such as using the colorization or the design choice, sharp, smooth, focus, detailed. So these are the different UI specific prompt we are going to add in our code so we could enhance our prompt. So these 2 properties we are going to add in the next video. So finally, the code which we have created in this project here, the web UI plus the backend.py along with the Stable Diffusion TensorFlow code is all going to be pushed into the GitHub repo. So here is the code, web UI code part 1, which we have just added. So git. So this code has been pushed from my local machine to the DeepWorks GitHub repo. Here is the DeepWorks GitHub repo. Looking at the Stable Diffusion UI, here you can find the code, and based on the work we have done today, we have added this tab. We have also added the prompt to image generation tab without some of these settings, and we have also updated this tab. So in the next video, we are going to add some of these settings as well as this brand new tab to save as well as the load the previously created images along with their prompt. So that's where we have completed our part 1 of this video. In the part 2 of the video, I will be adding more code on the top of the current project. So thank you so much for your time spending with me in this video, and I'm looking forward to seeing you in my next video. Until then, thank you so much for your time.